Solve by completing the square. 4x squared plus 12x plus 3 equals 0. In order to complete the square, we want the coefficient of our squared term to be 1. So first, we're going to divide both sides of our equation, or each term in our equation, by 4. We have x squared plus 3x plus 3/4 is equal to 0. Now we want all of our variable terms on one side and our constant term on the other. So we'll subtract 3/4 from both sides to get x squared plus 3x is equal to negative 3/4. Now we're ready to complete the square. We want to add the square of half of the coefficient of x. Our coefficient on x is 3, so we want to add 3/2 squared to both sides of the equation. 3/2 squared is equal to 9/4. Adding 9/4 to both sides, we have x squared plus 3x plus 9/4 is equal to negative 3/4 plus 9/4. Now we have a perfect square trinomial on the left side of the equation. So we'll write that as the binomial squared. So we have x plus 3/2 squared. And on the right side, we have minus 3/4 plus 9/4, which is 6/4 or 3/2. Now we're ready to use the square root property. The square root property tells us that x plus 3/2 is equal to the square root of 3/2, or x plus 3/2 is equal to negative the square root of 3/2. In both of these equations, we can rationalize the denominator on the second term by multiplying by the square root of 2 over the square root of 2. And we have the square root of 6 over 2. So our solutions are x is equal to negative 3/2 plus the square root of 6 over 2, or x is equal to negative 3/2 minus the square root of 6 over 2. Notice that we can write each as a single rational expression. Our solution set is the set containing negative 3 minus the square root of 6 all over 2, and negative 3 plus the square root of 6 all over 2. We can check these solutions by substituting into the original equation and finding out that they do satisfy the original equation. And note that we could also write this as the set containing negative 3 plus or minus the square root of 6 all over 2.